Welcome my people. So this video will just focus on question number 2 from section C of science paper 2 for the 2024 for GCE. So this is the chemistry, and the question reads: Elena added excess calcium carbonate. So you need to know that this is called a metal carbonate. So we have excess metal carbonate, which is calcium carbonate, with the chemical formula CaCO3 to 50 cubic centimeters as a volume of 0.10 moles per decimeter cubed. So this is the concentration. Then we have the volume of dilute hydrochloric acid. So it's a reaction between a metal carbonate and an acid. So you need to remember from the properties of acids, what are the products that we should expect whenever an acid reacts with a metal carbonate. So that is a part that is also very important. So if you look at the first question, we need to construct a balanced chemical equation for the reaction, including state symbols. So before we look at this equation, first I need us to look at the reaction if we have an acid plus any metal carbonate. So here we are going to have three products. The first one is salt plus water plus carbon dioxide. So it's very important to understand this statement before you write equations like this. So the acid is hydrochloric acid, and we are given the chemical formula, which is HCl. The state of acids, so they are in aqueous phase, plus C. Calcium carbonate is given, so we have CaCO3. The state is solid. Now for calcium chloride, the salt that will be produced, we need to make sure that we understand the valences. So chlorine is coming from group 7 and it has a valence of 1. Then calcium is coming from group 2 and it has a valence of 2. So if we use the crisscross method here, the chloride will have a subscript of 2. So never make a mistake of forgetting that subscript, because it is going to ruin a lot of things. So I'm going to write calcium, then the chloride, I'm going to put a 2 here. So this will be aqueous, plus water is known, H2O, plus carbon dioxide, CO2. So we've written the chemical equation, but we just need to make sure that this equation is balanced. So we can see that the calcium, there is only one here, there is only one here. So the calcium is balanced. Chlorine is not balanced, hydrogen is not balanced. So since we have 2 atoms of chlorine on the product sides and 2 atoms of hydrogen on the product sides, we are going to put a 2 in front of HCl. So as we can see, the equation is now balanced. So for the first part, this is the final answer. Right, so we can now go back to the next question, B1. The volume of gas produced. What is the gas produced? Carbon dioxide. In the first 2 minutes is 24 cubic centimeters. Calculate the average rate of the reaction over the time, 2 minutes, in cubic centimeters per second. So the formula, we are going to say average rate is equal to, so since we are given volume, we are going to say change in volume divided by change in time. So it depends with what you are given. Sometimes this formula can be mass over time if you are given mass, or concentration over time if you are given concentration. So you have to look at what you are given. So if you are given a volume, it's volume over time. Now, before we make calculations, you have to make sure that the time is in seconds, unless you are taught. Now, if you look at this question, we are told 2 minutes, so we need to change the 2 minutes into seconds. So how do you change minutes into seconds? Remember, 1 minute is equivalent to 60 seconds. So we are going to take these two, you multiply by 60. Or we can say 1 minute is equivalent to 60. So to move from 1 minute to seconds, you multiply by 60. Then from second to minutes, you divide by 60. 2 times 60 is 120. So the time is 120. Now what is the volume? The volume is 24. You write 24 cubic centimeters over, we have 240. 120, not 240. So 120 seconds. So 224 divided by 120. I'm getting 0.2 cubic centimeters per second. So this is my final answer. We move on to question number 2. The learner repeated the experiment using 50 cubic centimeters of 0.10 moles per decimeter cubed of ethanoic acid. So the second experiment, the learner used ethanoic acid instead of hydrochloric acid. So if you look at ethanoic acid is an organic acid, therefore it is a weak acid. So the second one, the learner used a weak acid. Now use the kinetic particle theory to explain why the rate of reaction is lower with ethanoic acid than with hydrochloric acid. So how do you define a weak acid? So a weak acid is a type of acid that ionizes partially. For a strong acid, it ionizes completely. So if a weak acid is ionizing partially, it means that the concentration of ions of ethanoic acid is lower than the concentration of ions in a hydrochloric acid. And remember, concentration is one of the factors which affects the speed of a chemical reaction. When you increase the concentration, the rate of a reaction increases. When you decrease the concentration, the rate of reaction decreases as well. So the concept that was here was that the reaction will be slow because ethanoic acid number 1 is weak, and because it's weak, it's going to ionize partially. Because of that, the concentration of ions will be lower than that. So let me see if I can summarize. So number 1 will say ethanoic, because ethanoic acid is weak and ionizes partially, resulting in a lower concentration of ions. We move on to number 3. How would the learner remove the excess calcium carbonate from the solution in A? So excess calcium carbonate, we are looking at the unreacted reactant. So we can just use filtration because the calcium carbonate will remain unreacted. So we'll say filtration. So we have the filtration as the final answer. Number C1, we have, C, methane, CH4 is a greenhouse gas. Then what do you understand by the term greenhouse gas? So say is a gas that traps heat in the atmosphere. So in the atmosphere, contributing to the greenhouse effect and global warming. Now for the last question, the percentage of methane by volume in the air is 0.00014%. calculate the mass of methane in 1000 decimeter cubed of air at RTP. So mass is equal to number of moles multiplied by the molar mass. So the molar mass can be found since we are given the chemical formula. So we'll say molar mass, Mr, is equal to, from CH4, there is one atom of carbon. So we'll say carbon multiplied by 1 plus hydrogen times 4. The mass number for carbon is 12 times 1 plus 1 times 4. So 12 plus 4 giving us 16. So 16 is the molar mass for methane. Now what is left is now we need to find the number of moles. So how can we come up with the number of moles? We are given volume. So volume is given is this one, and the condition, which is RTP. So to find the number of moles given this data, we'll say number of moles is equal to volume. This is now more concept divided by molar volume. So volume is 1000 decimeter cubed, and we are not going to change since it's already in decimeter cubed, divided by 24. As long as it's RTP, you divide by 24. So 1000 divided by 24, I'm getting 41.666, which is, we just say 41.7. So this is now that I'm going to put here. 41.7 times Mr is 16. So if you multiply by 16, I'm getting 666.666 grams, which is 66.7 grams. So as you can see, it's also very simple. So that's it for this video. Thanks for watching.